Today we're going to decompose functions, right? And so we're going to start with like an f of g of x. And the end game is going to be for us to find an f of x and a g of x from which that more complicated function came. And that's a skill that you need to take with you to calculus. So we're going to start here. So to do that, to decompose a function, to decompose a function, we want to find two functions f and g such that h is f of g. And a good tip or a trick to do that is we want to look for an inner function and an outer function, right? So for example, if I have this one here, h of x is equal to 3x minus 1 squared. The way I like to see it is, if I zoom out, right, what's like an outer shell of a function that I can recognize here? Something squared, right? On the outside, I have something squared. And then let's say now, like I fly in and I zoom in, what's inside of the x squared? The 3x minus 1. Okay? Yeah.
So is it kind of like the parent function?
Kind of, but you have now like two different types of parent functions, right? So f of x then will be x squared, and g of x will be 3x minus 1. And just as a check, right? If I were to find f of g of x, right? Then the blue 3x minus 1 will go in here, and it will be 3x minus 1 squared, right? So that's what we're doing. All right. Of course it makes sense. It's math. So let's go here, right? So what will be a possible f and g here? What do you think? Yeah.
1 over x squared and x plus 2. Yeah.
That's definitely a possibility. 1 over x squared and x plus 2. All right? And there could be more than one possibility, right? What could be another possibility? This is what I would go with. You could also do, for example, x plus 2 squared and 1 over x, right? But this is what I would go with. All right, what about the other one? What about the other one? The absolute value.
F of x be minus 3 because it's outside of like the.
So you want.
Or is that only for front?
You want your f of x to have a variable for you to plug in the other function.
Oh, so x minus
absolute value of x minus 3. Because what is it that you've got here? You've got some absolute value minus 3. You want to write a template into which you can insert another function. So what would g of x be then? 5x plus 2.
Wait, so do you not need the. Oh, wait, no, you don't.
Okay? All right. All right. So next, I want to talk about end behavior and sort of like limit behavior here. All right? Okay. So you see the bottom here, describe the behavior as x approaches infinity. This is end behavior. But I also want to talk about what happens as a function approaches to this function as x approaches 0. And both of these things are super important in taking with us to calculus. All right, so here I want to find basically the limit of f of x as x approaches 0, but I'm not going to graph it and look at the graph. I want to do it mentally. I want to I want to reason through it, right? Okay. So what I have here is 1 minus 1 over x. Okay? Is it a question or a comment? Okay, hang on. Let me walk you guys through this for a little bit. So what I want to do here is, here's where the variable is. And I want to think about what happens as that variable becomes very, very small, right? So in general, if you have 1 over x, And if the denominator gets very, very small, what happens to 1 over x? It becomes bigger and bigger and bigger, right? So for example, 1 over 1 is 1, right? 1 over 1/2, now I made it smaller, is what? 2, right? 1 over, now let me make it smaller, 1/10, that's what? 10. 1 over 100, that's even smaller in the denominator. What's the whole function going to be? What's the whole ration? That's going to be 100. So do you see how as the denominator gets smaller and smaller, the fraction itself gets bigger and bigger and bigger? So as x gets tiny, almost close to 0, like 0.000005, what's going to happen to the whole thing? It's going to get bigger and bigger and bigger. So it's like that. So let me write this. So this is like limit as x approaches 0 of 1 minus 1 over x. So as that x gets super, super tiny, 1 over x gets really, really big, and it starts approaching infinity. Does that make sense? Right? That the fraction 1 over something tiny will be infinitely large. So now what I have is 1 minus a number that's infinitely large. So what do you, like, what's 1 minus 1,000? Right. What's 1 minus a million? Negative 999,000, blah, blah, blah. What's 1 minus a trillion? Negative, still a number that big, right? So 1 minus an infinitely large number then will just be negative an infinitely large number. Okay? Right. So this is just negative infinity. All right? So how did we do that? We said, okay, this number x gets really, really tiny. That means the whole fraction gets really, really big. It approaches infinity. 1 minus an infinitely large number is that. Now, I want to make you guys aware of one thing. We can never actually write an expression like this. You can never write 1 minus infinity. That is not correct, because infinity is not a number that's defined. So you can't have that in an expression. You can think it 1 minus, and even me, like I never say 1 minus infinity, right? If you heard me, I always said 1 minus an infinitely large number, right? Because what's infinity? I don't know, right? So we can never write it, we can never speak it, and if you happen to write it, like you gotta erase it before you get caught, right? Like it's one of those things, yes? Don't get caught with it. It's like, it's not cool. All right? Questions? Okay, so now we want to find the limit of f of x as x approaches infinity. So this is the limit as x approaches infinity of 1 minus 1 over infinity. So now, what happens to a fraction? Oh my gosh, I just wrote exactly. I just wrote it. Oh my God, see, I was just caught. You guys didn't see that. So what happens as this x gets infinitely large? What happens to the whole fraction as x gets infinitely large? It gets smaller and smaller and smaller, almost like 0. So 1 over like 100 trillion is 0.0000. It's basically 0. So then 1 minus 0 would just be 1. Okay? So as x gets really, really large, so 1 over 1 is 1. 1 over 10, 0.1. 1 over 1,000, 0.001. 1 over a trillion, 0.00000 whatever, 1, right? So as x gets really, really large, this whole fraction will become tiny. It'll almost be 0. 1 minus such a number is about 1. Okay? So imagine like 1 divided by something, right? Imagine you've got 1 pizza and you want to divide it by, among 2 people. How much does each get? And then imagine you've got 1 pizza and now you want to divide it between like 1,000 people. How much does each get? Practically 0. Okay? All right. Any questions? Okay. I want you guys to be comfortable reasoning these out, a question like this will be on your test, right, where you have to like reason things out. And there are some problems on the homework as well. All right. Lastly, let's take a look at this. So here we've got f plus g of 0, right? You're given a function. You've given a graph. On the graph, you've got f of x, g of x, h of x. And what you want here is f plus g of 0, which is like f of 0 plus g of 0. And so you just have to go on the graph. F of 0 is -6. What's g of 0? What's g of 0? Also -6, about. So that's -12. Okay. Now here, I want f of g of -4. Right? So what's g? G is in red, right? We start from the inside. So what's g of -4? You're sure? Oh, wait a minute. Sorry. Yes, g of -4 is -4. And now f of -4 is also -4. I know. Okay? Super cool, yeah? So with that, like, we could do like a whole bunch of things, right? This is from your homework, and there was a couple problems. Yeah, there were a couple problems on the homework, and I always try to, whatever homework I assign, I always try to do a couple of examples in the notes, right? So, okay, so that much for this. So now